Hey, this is my engine final assignment. Sorry for the voice, I'm a bit sick right now, but I'll try my best. So I have this separated into the main scene and then two separate other demo scenes because I have to showcase some other stuff, including the mirror. But I'll run the demo scene first. And then ignore, excuse me, what happens, or what shows up right away. That's just for the testing stuff I'm going to show. Once I zoom out, that'll be the actual scene. So the actual scene is here. I have this terrain set up with this mountain height map. I have a flat plane serving as like ice in the background. Texture light, the shader is applied to the terrain, the ice, pretty much everything except my snowman, which is the one that takes 3 point lights. So you can see the point light, the green one, reflecting onto the front and then the blue one reflecting onto the back. My moving light source is a spotlight here, so you can see it affects both the bear and the terrain. And then I'm using my color light without texture on these crystals here. And of course the skybox in the back is this mountain scene. But as for, I'll go down the grading dock first. So all my pre-made models are within this enum that we already had. So box repeated texture is this one that shows up here. I have this value to change the size. I can make this smaller. And then that'll reflect it. If there's something that doesn't take a size, it doesn't matter. It'll just default to whatever the default is at, which I believe is 6 right now. So there's 14. If I do the pyramid, for example, but I don't give it a size, it'll default to 6. There you go. And then I have this stuff with like the single UVs, excuse me, the stuff that I already showcased on my previous assignments, my other videos. But yeah, I'll show the model tools to see how those are made right now. And then my sphere is in a separate demo because there's something added with the mesh separator that doesn't allow for meshes to share indices or something. There's an assert in there somewhere. This one right here, triangles on one mesh shouldn't share vertices, which is actually how my sphere is made. So my sphere is in a separate demo, which is right here, I believe. And then this is how I had the sphere with the 3 point light shader. But yeah, this is different. So I'll go back to here. 1 second. So for model tools, this is where I create all my models with the size modifier taken as a parameter. Yeah, I'd already shown these in previous assignments, but they're all still here, kind of just accumulating. The skybox, I believe that's the next thing. Actually, external models. So the model that I have using different meshes, well, you saw that there's a bunch of external models loaded from files. You can see the file loading in right here. But for example, the cottage takes 4 different textures, and I can assign them with the number. So if I want to change whatever 2 is, I can change this here. And I'll use the snowman texture instead. And then say for this one I want to use something else like the UFO. If I run this, those changes are going to be reflected on those specific meshes of the mesh object. Now that's really the only reason I had the cottage there. I was going to use a different mesh, something that looked nicer, but the Azul converter didn't work on all the models that I used that had separate meshes. But you can see here, so now the body is the UFO texture, and then the door is using the snowman texture. So I'll go back to that once I get to the graphics objects, but I'm going to the list right now. For HLSL shaders, nothing crazy here, so I have all the basic ones, the light with texture, color, texture without light, and then texture with my 3 point lights. They're all set up the same. For example, with my 3 point lights, I have a struct of light parameters, or sorry, constant buffer of light parameters that takes the directional light and the 3 point light, since I want the directional light to be shared amongst all my shaders to look natural, as well as eye position. In all my shaders I also have this fog data, so if I run this and then I zoom out far away enough, you'll see that the fog starts to overtake. It's a white color, and it'll fade into that white. And those parameters are set in the shader as well, so if I just zoom out here, you'll start to see that these things fade, and it's based on position. The reason that the cottage isn't fading is because I scaled this one up. Like I said, I couldn't find a mesh with multiple meshes inside of it, so the cottage was what I had to resort to, which means that I had to scale it up, and of course it's not going to match the fog parameters, but everything else is fading out, as you can see here. Excuse me. The fog is calculated how you had shown us here at the bottom. So the user passes in that information by calling set fog parameters, and then if it's a texture, then you do the texture first and then the fog interpolation. So I'll go through here. So in my draw, there's something like send fog parameters for all my shaders, and then that's how that's sent. If I, excuse me, if I comment this out, which means the user forgets to do it, there's a default for a really far away range, so that there's technically no fog unless you go extremely far. So that's my default case. So I'm going to zoom out here, and then you'll see that things don't fade out like they used to fade out around here, but they're all still staying, you know, like visible. So that's how I have fog set up. The next thing, let's see, besides the shaders, I don't think I have to go into detail. You already know how these work, and they're all pretty much the same except for using different constant buffers or different data. My Skybox class is its own class called Skybox, where I send the device, the shader, the texture, and the size that I want, so it's easier for the user, and then the actual class just makes that model, passes in the texture and shader, and then when render is just called without parameters, and it already knows what to do. So that's done. Here all I do is call pSkybox render. This world doesn't have to be sent in the draw. I think I was messing with spinning. But when I initiate it somewhere up here, pSkybox, all I have to do is call pSkybox equals new skybox, pass in the texture shader, the texture, and the size. Of course I can make this smaller, and then it won't really be a skybox anymore, but just to show that the changes are reflected. So there you go. It's much smaller, of course. My terrain works the exact same way. So to be easier to the user, all they have to do is specify they want a new terrain. They pass in the device, shader, texture, height map, the repetition of the UNV, and the width and height of it. And it does almost the same thing as a skybox. So in DXApp, when they want to create a new terrain, all I have to do is call pterrain equals new terrain, pass in all the stuff that I said, including the height map file. Now they can specify how many times the texture is repeated, the size of the terrain, and then the height. If I change this to something more drastic, you'll see that change reflected. And the terrain I had already gone over in a previous assignment, so I won't go into too much detail about how I did the actual model, but I'll just show it briefly right now. So as you can see, the height became more dramatic, the bear became obscured, so do the crystals. It does look a bit better higher like this, but I wanted to just showcase at a more level height. Excuse me. So all you have to do again is just call render on that. You don't have to pass in any parameters. It's just pterrain render. It's kind of like the graphics objects, and then all you have to do is send the information. Again, I have random stuff in draw that shouldn't really be there because it's only sent once. But I think it's just some stuff I forgot to clean up. So if you send it here, same thing, of course. And so that's how I encapsulated the skybox and the terrain to make it easier for the user in the same way that the graphics objects are working. So there you go. So for my graphics object classes, you had already given us the base and the color, and these work the exact same way. So the new one, for instance, like the 3-point lights, for texture, I'd have to pass in an array of texture pointers, and then I pass in the model, and then I create a new array of texture pointers. I get the mesh count, and then I iterate through that to set the materials as well, since I need both materials and texture. For set texture, if I just pass it in without a parameter, it assigns all the meshes that same texture. Otherwise, if I specify a number, it'll use that texture for that specific mesh. Set material, I can either specify a number or without one. If I don't, then it just sets that material for all the meshes. Otherwise, it sets it for that specific mesh. Set world just sets the world, of course, and then when I call render, bind the vertex index buffers, go through the list of meshes, send the world and material for each one and the texture for each one, and then render them. And then you saw that working with cottage, how you can separate the meshes and with different textures. And then my 3-point light shader is this one here, where I have a separate, or I have that struct with 3-point lights, and then at the end I have to compute light 1, 2, and 3 to get them all. And then of course in DXEP, or actually call it, I have to set those parameters. So text light 3-point, I have to set them all to whatever values I want. And then again, you saw those on the snowman with the crystals. And those are affecting both the snowman and the terrain, which is just using the texture light. For other graphics objects, again, they're working the same way. Texture, I had to use an array of texture pointers. For color light, it's just an array of vector pointers for the color. And again, they work the exact same way. If I want to set specific material for each mesh, or just assign them all the same one. And then the way that the user creates those is really simple. All they have to do is say if they want to create a graphic object color light like the crystal, they pass in that shader, the model, and then they set the material, and then they set the world, and then all they have to do down here in render, or in draw, is call COL light crystal render, and then that's all they have to do after they set the context and send the appropriate parameters for light and fog. And that's how they're all working, so you can see I'm just calling render on all of these. But yeah, that's how my graphics objects work. For mirrors, I have this as a separate demo. So I believe it's this one. I already showed it last week, but I'll just run through it really quickly again. So this is working with just texture, colored light, and texture light. Sorry, so you can see the light is being reflected appropriately, so you can kind of see the shine on here, and the shadow on this back side is also reflected over here. The texture, of course, doesn't have any light, so it's not reflecting it. But the frigate and the box are. And then you can see the stencil is cutting it off here. There's nothing behind. But yeah, that's how the mirror is working. I chose not to implement it in my demo scene because it was a bit too complicated in terms of how long the draw was. But yeah, it's working fine. Just trying to quickly get a look at this checklist and see if I missed anything. So I'm going to go through my actual demo scene now, since I kind of skimmed over it. Again, my moving light is that UFO with the spotlight. You can see here it goes over the bear, and then it reflects that change, of course. My 2 spotlights here, or sorry, my point lights. So snowman is taking the 3-point light shader as a 3-point light graphic object, and the blue and the green are reflected onto it, as well as onto the texture. And I had to pass on the same values, of course, so that the point lights are going to be in the same position for both the texture light and the 3-point texture light. My terrain, again, is using the height map that I passed in. I can change those values. I can change the value for the skybox here. This cottage was scaled up again, so I had to use this one since I wanted to showcase the separate meshes. But of course, that's not going to be affected by light and fog as it should. So all this other stuff is set as a scale 1-to-1 model. So I'll show that in DXEP. So these are all the actual models I'm using. You can see anything I'm actually using has a scale of 1-1-1, including the bear, snowman, tree. So I had to import these into Maya, freeze the transformations, and then pass them in. But again, I have to do that for consistency with light and also with fog, so I don't have to change parameters for each one, and they're all consistent with each other. The texture mapping on the bear, I usually had to flip the textures because they were upside down for some reason. But you can see it's matching appropriately. Same thing with the snowman here. So let me see something really quick. Multiple point, multiple spot. Excuse me. Yeah, so for the shader with the multiple lights, again, I chose the 3-point lights to showcase my actual shader class for that. Nothing special. I just have the 3-point lights as data members, so point light data 1, 2, and 3. And I pass those in a struct, and then I update the sub-resource with that information. And then the shader, the HLSL shader, as I already showed, takes care of the rest by computing the point light stuff. The fog I already showed, including if the user forgets to put in any parameters. And then in case I missed something else, I'm just gonna go over my DXEP. So this is where I set my matrices. I initialize all my light parameters for the things that take light. Otherwise, if there's just a texture shader, I just do new texture shader or new shader color. I import all my models and all my textures. For the cottage, for instance, I have 4 textures for it. I set the world and material for everything that needs it. And then this is where I initialize all my stuff. I try to streamline it as much as possible, so all the user has to do in the end here is call render, unless the parameters change during the draw call. Yeah, that's my final scene. Thanks for watching.